Let's see another question from mechanics. Here we have the system which is released from rest. Spring initially it is in natural length. Spring constant given K. Maximum extension in the spring is given as x naught. And A1, A2, A3 are the acceleration of the given blocks. Okay. More than one option is correct, so we have to check all the options. First of all, let's concentrate on the first option. So here you can see that if this block accelerates rightwards with acceleration A1, it is connected to this pulley with this string. So the pulley must move down with the same acceleration. So this is nothing but acceleration of the pulley. Okay. And this pulley block system Atwood machine constraint we very well know, acceleration of m, that is this block, with respect to pulley, this is equal to negative of acceleration of 2m, that is this block, with respect to pulley. Okay, what is acceleration of m with respect to pulley? Its acceleration is given as a2, acceleration of the pulley is a1. So acceleration of m with respect to pulley will be a2 minus a1. This will be negative of, similarly this will be a3 minus a1. Okay, so this is same as the given option A. So you can see that this is the correct option. Okay, now for other options, what is important is you have to simplify this diagram. Okay, so let's simplify this diagram to understand it better. What I want is this whole system I want to simplify, otherwise this motion looks complicated. Okay, so now first objective is, what I want is, I want to convert this Atwood machine which consists of two masses m1 m2. I want to convert it into a single mass system. So what should be this m? Okay, right. So you can see that how I do it. Let's say here tension is T dash, so here this is mg, so T dash will be equal to mg, and here if tension in the string is T, here it will be 2T, and using Atwood machine calculations, T I very well know. So this 2T is nothing but 2 times of T. T is 2 m1 m2 g by m1 plus m2. This is from Atwood machine calculation. Okay, and if these two systems are equivalent, their tensions must be same. So that means T dash must be equal to 2T. So let's equate it. So this mg will be equal to 2T, which is 4 m1 m2 g divided by m1 plus m2. G will be cancelled, so m comes out to be 4 m1 m2 divided by m1 plus m2. So this is how I can replace this whole system by a single block and string, and this will be the mass of that single block. Okay, so let's use this result to simplify the diagram which is given in our question. Okay, so now what I can do is I can redraw this diagram. This spring block will be as it is. Instead of these two blocks, I can just write a single block, let's say of mass m. This m I can write it as 4 m1 m2 divided by m1 plus m2 as we have calculated. So this will be 4, two masses are m and 2m. So m into 2m divided by m plus 2m, which is 3m. So this will come out to be 8m by 3. So this capital M is nothing but 8m by 3. Okay, right. So now motion is pretty much easy to understand. This is on the ground. It's like this. Okay. So now second question is x naught. X naught is the maximum elongation. So you can see that as this moves down, this has to move right. You can see that this is connected by inextensible string. So at maximum elongation, let's say maximum elongation is x naught. So this 2m will move a distance x naught. This capital M, which is 8m by 3, has to move the same distance x naught. Okay. And at maximum elongation, it will come to rest for an instant. This will also come to rest for an instant. Okay. Right. So at maximum elongation, I can say that kinetic energy of the system will be 0. Okay. Initial kinetic energy is 0 because system is released from rest. So I can say that change in kinetic energy is 0. So therefore net work done has to be 0. Now here two forces are doing work. Work done by gravity plus work done by spring force. Sum of these two must be 0. Okay. What is work done by gravity? This capital M, which is 8m by 3, is moving downwards by distance x naught. So work done by gravity will be positive and its value will be m, that is capital M, this will be 8m by 3 into g into x naught, mgh. Okay, this will be positive. Work done by spring force will be negative because displacement is rightwards, spring force is leftwards. So this will be minus half k x naught square. This will be equal to 0. So on solving, this x naught comes out to be, as you can see, this will be 16 mg by 3k. Okay, which is different from option B. So therefore this option B will be incorrect. Okay. So now to look option C and D, what I can do is I can further simplify this situation. These two blocks I can draw as a single block because you can see that they behave in the same way. This moves rightwards, this has to move down. So what I can do is, instead of these two blocks, I can just draw this pulley and just one block, whose mass will be sum of these two blocks, which is 2m plus 8m by 3. So this will be 6 plus 8, this will be 14m by 3. Okay, so this is nothing but one block of mass 14m by 3. It is connected with this spring. Okay, so here it's very easy to calculate its time period. Its time period will be 2 pi by omega, which I can write it as 2 pi total mass is 14m by 3 by k. This is 2m under root of m by k, m effective. So m effective is nothing but 14m by k. Okay, so from here I got the value of omega. What will be omega? This is nothing but under root of 3k by 14m. Okay, now what is C part? Velocity of 2m connected to a spring, that means this velocity, and we very well know its velocity and its velocity will be same. That's why I combined these two. Okay, when elongation in the spring is x naught by 2, you very well know maximum elongation is x naught when it comes to rest. Okay, so x naught by 2 is nothing but its mean position, and at mean position we very well know what will be the velocity. Just treat it as a simple one spring one block system doing SHM. Okay, so x naught is the maximum elongation, so x naught by 2 will be mean position, and at mean position velocity we very well know it is maximum, which I can write it as amplitude into omega, and amplitude is nothing but x naught by 2. Okay, because as you can see the maximum elongation is x naught, so amplitude will be x naught by 2. This we can easily understand like this. Simple spring block system, if this is the mean position and this is the maximum elongation, which is 2x naught. Okay, so if maximum elongation is, I'm just writing it as let's say x max, so this distance is nothing but x max by 2. This is nothing but x max by 2. So if somebody asks you what will be the amplitude, so you can see that about this mean position it oscillates like that, so as amplitude will be x max by 2, that is maximum elongation by 2. So therefore this amplitude I can write it as maximum elongation by 2 into omega. Omega is 3k by 14m under root. Okay, which is the same answer given in option C. So therefore this will be correct. Okay. For D is very simple. They are asking acceleration of A1. A1 means 2m, but we very well know acceleration of these two will be same. That's why I just simplified this diagram into one block system. Okay, so acceleration when elongation is x naught by 4. Okay, so in simple one block spring system, acceleration I can write it as omega square into elongation or compression. Here elongation is given as x naught by 4. So this will be the acceleration. Omega square I very well know this will be 3k by 14m multiplied by x naught by 4. So this will be 3k x naught by 42. Okay, right. So you can see that this will be your answer, and that's what is given in a problem, as you can see. So this option will also be correct. This will be the acceleration, omega square x. This is nothing but omega square, I put it here, and x here is given as x naught by 4. So I put it over here. So here I forgot to put this m. This m should be there. Okay, this m will be there. So here the answer will be A, C and D. Thank you.